Assalamualaikum warahmatullahi wabarakatuh. So we are from class DKA 3B going to be presenting about the cone penetrometer. So my name is Zaim Helmi bin Ahmad Sharifuddin and my registration number is 01DKA20F2064 and my team member is Al-Baki bin Abdul Rahim. His metro number is 01DKA20F2038 and Muhammad Irfan Alif bin Zanira. His metro number is 01DKA20F2060 and lastly is Muhammad Taufik Hidayat bin Hassan and his metric number is 01DKA20F2067.
Hi and Assalamualaikum. My name is Muhammad Irfan Ali bin Zanira and my matrix number is 2060. So for introduction, the water concentrations that define transition between the solid, plastic and liquid forms of a specific soil type are known as Atterberg limits. The test is only applicable to cohesive soils with significant silt or clay percentage, and they cannot be done on sands or silt with a high sand percentage. The Atterberg limit can be used to distinguish between different types of silt and clays. These tests are mainly used on clay or silty soil since these are the soil that expand and shrink due to moisture content. Thus, these tests are used widely in the preliminary stage of building any structure to ensure that the soil will have the correct amount of shear strength and not too much change in volume. It expands and shrinks with different moisture content. Hi and Assalamualaikum. My name is Muhammad Irfan Ali bin Zanira and my matrix number is 2060. So, for objective to determine a liquid limit and plastic limit and to classify the soil sample.
Assalamualaikum. My name is Muhammad Taufik Hidayat bin Hassan. My matrix number is 01DKA20F2067. Today I would like to present about the apparatus. First is liquid limit device. Second is picture of moisture content metal container. And the third is flat plate glass. For the fourth is picture of electronic balance. And the fifth, porcelain sets, spatula and distilled water. And the last one is picture of drying oven. Procedure. First, sieve 300 grams of dry soil, pass through 435 micrometer test sieve, number 40 sieve. Step 2. Place about 300 grams of dry soil plus to 425 micrometer. Step 3. Adding the distilled water and start mix the soil with the spatula for at least 10 minutes. Step 4. Place the portion of the paste soil in the cup and press the soil paste against the side of the cup to avoid the trapping air. Make sure the top surface is finely smooth of level with the rim using the straight edge. Next, lock the cone and shaft unit near the upper end of it. Travel and lower the supporting assembly carefully. Lower the stem of the die gauge to make contact with the top of the cone shaft. Make sure, next, lift out the cone and clean it carefully. Repeat step 5 for reading up to at least 2.41 as one sample. Record the dye reading to the nearest 0.1 mm for R2. R1 is example for R1 and this is for R2. Next, we calculate the average R1 plus R2 divide to 2. Next, step 6, take the moisture sample about 10 gram from the area penetrated by the cone. Step 7, weigh the empty container and moisture content container. Remove the rest of the soil paste from the cup. Adding more water to the soil paste in the evaporating dish and mix roughly. Repeat step 4 until 7 for the test 2, 3 and 4. Remember, take a moisture sample for every sample test 1, 2, 3 and 4. Step 8, put into oven and let dry for 24 hours. Step 9, weigh the moisture content after 24 hours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zaim Helmi bin Ahmad Sharfuddin and my registration number is 01DKA20F2064. So in this part of slide, I'm going to be presenting about the data and conclusion for liquid limit. So the first is mass of wet soil plus container gram. The first one is 24.21 and the second one is 25.32 and the third one is 26.88 and the fourth is 28.33 and the second is mass of dry soil plus container gram. It is 18.57, second one is 18.65 and the third is 18.89 and the fourth is 21.22. Mass of container gram is 5.71, 5.75 and the third is 5.72 and the fourth is 5.88. Mass of mass of moisture is 5.64 and the second one is 6.67, the third is 7.99 and fourth is 7.11. And mass of dry soil gram is, and the first one is 12.86, the second is 12.90 and third is 13.17 and fourth is 15.34 and moisture content percent is 48.86 and 51.71 and the third is 60.69 and the fourth is 46.35. For cone penetration, millimeter is 15.6, 15 and second one is 18.1 and 18.2 and for the third is 20.9 and 20.8 and fourth is 23.5 and 23.4. For average penetration per millimeter is 50, and for the first one is 15.6 and the second one is 18.2 and the third is 20.9 and the fourth is 23.5. That's all for me. We're going to find the plastic limit value. So the first one is mass of wet plus container gram. The first one is 20.45 and the second one is 20.5 and the third is 20.57 and the fourth is 21.22. For the second one is mass of dry soil plus container gram. So the first value is 16.24 and the second one is 15.85 and the third is 16.6 and the fourth is 16.8. Mass of container gram is, the first one is 5.78, the second is 5.74 and the third is 5.79 and the fourth is 5.86, and mass of moisture is 4.21, 4.22, 4.21 and 4.20, and the third is 4.52, and the fourth is 5.14. Mass of dry soil is first 10.46, and second is 10.11, the third is 10.32, and the fourth is 10.40. Moisture content is 40.25, the second is 41.54, and the third is 43.22, and the fourth is 49.42. For the moisture content average is 43.61. So in order to find the plasticity index, we have to draw a line in the cone penetration method chart in the graph that's shown in the slide. So liquid limit is 45 and plastic limit is 43.61%. Plasticity index is liquid limit minus with plastic limit. So we're going to get the value which is 1.39%. So the soil classification is low plastic. That's all for me. Thank you.
Now I will explain this question. This testing method, also known as the Casagrande method, and the cone penetration method, is used to describe fine grain fraction of soil and to specify the fine grain fraction of construction material in numerous engineering categorization system. Liquid limit, plastic limit, and plasticity index of soil are also used widely to correlate with engineering behavior such as compressibility, permeability, compatibility, shrink wear, and shear strength, either independently or in combination with other soil parameters. The liquid limit test is useful for classifying soils. The liquid limitations of different soils differ. After plotting the graph, the liquid limit obtained using the Casagrande method is 22%, while using the cone penetration method is 45%, whereas the plasticity for cone penetration method is 6.98, and Casagrande method 1.39. The soil classification for both of these is low plastic because both are less than 7. Next, conclusion. In conclusion, we were able to determine the percentage of liquid limit using this cone penetration test. When using a penetrometer, make sure the tip of the cone barely contact the surface of the soil sample to achieve an accurate reading of the depth of penetration. Ensure that it does not sink even a fraction of an inch below the surface of the soil sample. Since this will after the penetration reading. The plastic and liquid limit of the soil sample may be calculated using the British soil classification system, with the soil sample being categorized as clay with low plastic based on the liquid limit LL and plastic limit PL. Value obtained using the Atterberg limit test using the Casagrande device. The Casagrande technique has also been used to determine the liquid limit. This is due to the fact that each soil has a distinct liquid limit LL. That number is critical for calculating the plastic limit PI using the formula PI equals LL minus PL. That's all for me, and thank you.